Hello, geometry students, and welcome to the world of equations of circles. Now, in this lesson, we're going to explore how do we find the equation of a circle on a coordinate plane. So let's say I have a coordinate plane like this, and I have a circle center at the origin. This is 0, 0. Let me label my scale here. Let's call this 4, this 8, okay? And if I had a circle, let's say it was taking these points right here. Okay, I'm not as good as drawing circles as my students are, so I have to get some guiding points here. And you'll have to forgive the lack of perfection in my circles. Okay, but if I have a circle like this with a center of 0, 0, how do I find the equation so that I can graph this curve here? And this is something new. Normally in geometry, we've been graphing straight lines a lot, graphing a lot of polygons, triangles, quadrilaterals, and so forth. But here we're going to try to graph a curve here. So if I have just any point on here, and I'm going to call this point xy, how do I relate xy to the rest of the circle? Okay. So that brings us to the issue of what is it that makes a circle. How do we make a circle? So just a little bit of a review here. A circle has a center and it has a radius. Okay, and in this particular case, our center is 0, 0, and our radius, I don't know what the length of this is exactly, so we'll just call it r. So I have a circle with a radius of r and a center of 0, 0, and I want to find somehow to write the equation for the circle. Okay, so what is unique about this circle is that the distance between the center and xy is always r. This relationship is always true. Okay, so even if xy was over here, even if I have some other point over here, the distance between that point here and the center is still r. So we want to use that distance somehow in order to write the equation for the circle. And so when we're talking about distance on a xy plane, we got to use the distance formula. Now let me update here. The radius is r. Okay. So we use the distance formula. And for those of you who have forgotten, it is the square root of x1 minus x2 squared plus y1 minus y2 quantity squared, all of it inside a square root. Okay. So what is the distance between 0, 0 and xy? Well, it's r, right? So the distance from center to point xy is r, but it's also equal to the distance using the distance formula. So r is equal to the square root of x1 here, in this case it's just x minus 0 squared plus y1 here, it's just this point y minus 0 squared. So we get r is equal to the square root of x squared plus y squared. And what we can do is square both sides. Since we're talking about the entire circle here that goes all the way around, we want to be able to incorporate negatives and positive values. With the square root, we're only going to get positive numbers. So square both sides and you get r squared equals x squared plus y squared. Okay. And this is the equation for a circle with the center at the origin. So this is the centered, has to be centered at 0, 0, at the origin. Okay. And just to recap here, what this means is that if you wanted to graph this circle, you have to know the center, you have to know the radius, and you have to know this equation in order to graph the circle. Okay. And let's hit pause right here, and then I'm going to change my board and go to another example where the center is not at the origin. Okay, so now I'm going to draw another circle but instead of being centered at the origin, it's going to be centered at some other point. Let's say this point here is the center, and I'm going to go 3 over this way, 3 towards the top, 3 units towards the left, 3 units downwards, and that's going to help me draw my close to perfect circle. Okay, so you have a circle, the origin is down here, and it's not centered at the origin, and whatever this point is, we don't know, so we're just going to call it, make two variables here, h for the x coordinate and k for the y coordinate. It's a little hard to read, but this is a k right here, and that's an h. Okay. And I want to know what's the equation for the circle for any point x, y here on the graph, on the circle. So I have a point x, y. Here's the center. The radius is still r, so the radius, we'll still use the variable r to describe that. How do I write an equation using h, k, x, y, and r? Well, it's still the distance formula again, because one of the most unique things about the circle is that the distance from the center to any point on the circle never really changes. So if xy is here, the distance between that and the center is r. If xy is over here, the distance between this point and the center is still r. So for every single point on the circle, xy, whatever the coordinate is, we'll just call it xy because we don't know, but whatever it is, the distance between that point and the center is always equal to r. Okay? So I'm going to make use of the distance formula again. So I'm going to say the distance from xy to the center is equal to r. I already know this because it's from the definition of a circle. But r is also the distance using the distance formula. So that's the square root. It's going to be x1 minus x2. In this case, it's x and h. So x minus h squared plus y. y1 minus y2, or y minus k squared. And to square both sides, we get r squared is equal to x minus h quantity squared plus, let me make this neater here, plus y minus k quantity squared. And this is the general formula for the equation of a circle with a radius of r and the center of hk. And this also works even if h and k are equal to 0. Okay? And I just want to stress the point that this is developed by using the distance formula, because the distance between the point and the center is always the same no matter how you travel around the circle. So with this in mind, let's take a look at some examples where we try to write the equations of a circle. Okay, so now that we've gotten sort of the definitions of the equations of a circle down, let's take a look at some example problems. So in this first one, let's call this one number 1, this number 2, it asks us, write the standard equation of a circle, of this circle that's given here. And I've just jotted down the reminders here that we're going to use h and k to represent the coordinates of the center. The radius, the length of the radius is going to be r, and this is the general formula for the equation of a circle. So if you look at this circle here, these tick marks are 2. So let's look at here. This is the center of the circle. So the center for this one is 0, 0. And the radius is 2, 4, 6. So r equals 6. So that means the equation of this circle is x minus h, but h is 0 in this case, squared, plus y minus k, or the y coordinate of the center, that's also 0 in this case, squared, equals r squared, and r is 6 in this case. So let's simplify. You get x squared, because x minus 0 is just x, y squared equals 36. Let's look at this one. The center for this circle, looks like it's this point right here, which is 1, 1. And the radius, the distance from the center to one of the other points on the circle, looks like it's also 1. So that's a pretty straightforward example. So our equation is x minus h in this case is 1 squared plus y minus k, okay, but k is also 1 squared equals the radius squared. So this should be x. So x minus 1 squared plus y minus 1 squared equals 1. Okay? And this is the equation for this circle. Let's look at number 5 now. These examples use something a little bit different. Instead of giving you the picture, they just give you the center and the radius, which I think makes it even easier. Write the standard equation of the circle with the given center and the radius. So we use the same thing again. X minus h, in this case it's 1 squared, plus y minus k, which is 3 squared, equals the radius squared. So that gives me the equation of x minus 1 squared plus y minus 3 squared equals 16. Let's move on. Number 6. And feel free to ask the teacher to hit pause at any point and see if you can do some of these yourselves. And then we'll hit play again and you can see my solution. Okay, so maybe now would be a good time to hit pause. See if you can write the equation yourself and then hit play again and I'll show you my solution. Okay, so the center here is 4 and negative 7, so it's x minus 4 squared plus y minus a negative 7 squared, and just be careful with the parentheses here, is equal to the radius squared. So simplify, this comes out to x minus 4 squared plus y plus 7 squared, because y minus negative 7 is the same thing as y plus 7, equals 13 squared is 169. Okay. And so that does it for those problems. Let's look at some more. Use the given information to write the standard equation of a circle. So we know the center, but what we don't know in this case is the radius. Okay? Before it gave us the radius. Now we need to find the equation but to do that we need to find the radius. So I'm going to sketch just a little picture here. This is the center, and this is 0, 0. So I'll make a note here. This is the center, that's 0, 0. And the other point on the circle is 4, 0. And you can see from this picture that the radius is in fact 4. Or if you're not sure and you really want to prove this, we can use the equation of the circle, or the distance formula. Okay, so I know that the radius is equal to 4 minus 0 squared plus 0 or minus 0 squared, and the square root of the whole thing, which is the distance formula. So that means r is equal to the square root of 4 squared. This is because this is all just 0, and that's 4. Okay. So now that I know that the radius is 4 and I know the center, I can write the equation. It's x squared plus y squared equals 4 squared, or x squared plus y squared equals 16. Let's continue. Let's look here at number 8. The center is at 3, negative 2, so it's a little bit of a different picture here. 1, 2, 3, 1, 2. Let me label my scale. 3, negative 2, that's the center. And some other point on the circle is 23, 19. Okay, so that's way over here somewhere. It's 2319. Okay. And I know that somehow I'm supposed to draw a circle around this point, and that's a really bad circle. Again, I'm not as awesome as my student at drawing perfect circles. So now I want to know what is, this is 3, -2, what is the radius? I know the center. If I can somehow figure out the radius, I'll have my answer. So to find the radius, we just use the distance formula, because the distance between the center and any point on the circle is always equal to the radius. So the radius is equal to the square root of x1 minus x2, 23 minus 3 quantity squared, plus y1, 19 minus y2, 19 minus -2, so that becomes plus 2 quantity squared. So the radius is equal to the square root of 20 squared plus 21 squared. That's the radius is equal to the square root of 400 plus 21 squared, which is 441. And that's equal to the square root of 841. And I can leave this as is. Normally I would have to write this in simplest radical form, but you'll see in a minute why this isn't necessary. So the equation that we use for the circle again is x minus h squared plus y minus k squared equals r squared. And I know that h in this case is 3, so it's x minus 3 squared plus y minus -2 or plus 2 squared is equal to r squared. But I know that r is the square root of 841 quantity squared. So to simplify and give our final answer, x minus 3 squared plus y plus 2 quantity squared is equal to 841. And you see why I didn't really simplify this in this step, because I know that I'm going to have to square it later anyway. So even if I did the extra work, I would have to undo it later in order to get the final equation. And there you have it. This is a handful of examples on how to find the equation of a circle. When you're given a picture, when you're given a center and the radius, or when you're given the center and some point. Now in these examples here, we're given a problem of determining the diameter of a circle with the given equation. And just keep in mind that the diameter is equal to twice the radius. Okay? The diameter is equal to twice the radius. So here we know that this number is r squared. So I can say that r squared equals 100. Take the square root of both sides. R equals the square root of 100, or 10, and the diameter is equal to 2r, which is 2 times 10, or 20. In this example here, I know that r squared is 64. R squared equals 64, so r has to be equal to 8. That means the diameter is 2 times r, or 2 times 8, which is 16. And if you notice something about these problems, when it's asking for the diameter of the circle, we don't even need to look at the rest of this. We just need to look at the numbers that give us the radius. So I'm gonna maybe we'll pause right there for a quick moment, and then we'll look at these last couple of examples. So we have a couple problems here that says graph the circle x minus 4 quantity squared plus y plus 2 squared equals 16. And this is in fact the circle. And it says, given this line here, is the line a tangent, a secant, or a secant that contains the diameter? Okay? And keep in mind that a tangent touches the circle exactly once. A secant touches the circle 2 times. And a secant that contains the diameter touches the circle 2 times and contains, for it to be a diameter, it has to contain the center. So to do this, we really have to use graphing. And so I'm going to look at the equation of the circle here that's been given to us. Let me use a better pen here. I'm going to look at the equation of the circle here that's been given to us. And I'll write a note here on the side. The center of this circle is 4, -2. So the center is at 4, -2, and it's just the opposite of these numbers because the center is h and k, and this is x minus h, y minus k. So h has to be 4, k has to be -2. Okay. The radius is the square root of 16. So the radius is the square root of 16 because this 16 here is r squared, so that's 4. Okay. And with that in mind, I can draw my circle fairly well. So I'm going to draw the circle here. The center is at 1, 2, 3, 4, and it's down 2. So that's the center, and it's got a radius of 4. So to do that, I start from the center and I go 4 over. 1, 2, 3, 4, 4 down. 1, 2, 3, 4, 4 left, 2, 3, and 4 up. 1, 2, 3, 4. And so this is my, oops, this is my circle. Now I have this other line here. Let me circle this. I'll write this out here. Y equals x minus 2. And what I'm basically going to do is just graph this line and see how many times it touches the circle. So and if you need some help with graphing this line, I'll review this too. So we really just need 2 points, okay? Or better yet, I don't know why I said that. We already know the y-intercept, okay? The y-intercept is going to be -2. So I'll draw this in again, and we'll use it. So x and y. If I put in 0 for x, I'm going to get -2 for y. Y is going to be 0 minus 2, which is equal to -2. Okay? So 0, -2, that's this point here, okay? Which is one of the points on the circle. And we can try another point. Let's say I picked, I don't know, 2 for x, so that gives me 2 minus 2 equals 0 for y. So 2, 0, 1, 2, 0 for y. Use a ruler and connect these 2 points. So this point here and this other point here. And you can see that in this case, this is a secant because it touches the circle at 2 points. This is a secant. And by the looks of it, it clearly does not go through the center of the circle. So I'm going to end the lesson here. I'll give you a chance to try some of these other examples on your own so you get some practice, and we'll discuss this in class. Have a great day. Sincerely, have a great day.